Okay, I'm going to go through some of these problems, and then the key will be online. So first, you need to identify whether it's a 45, 45, 90 or a 30, 60, 90. So number one is a 30, 60, 90. So I'm going to draw a little 30, 60, 90 off to the side. This is the 30, this is the 60, and then write the ratios in. So it goes 1, the hypotenuse is 2, and this is root 3. So you can compare the two triangles. If this side's 1 and this side's 1, these triangles are actually congruent. So y is root 3 and x is 2. I don't really even need to set a proportion to solve. Okay, the second one, I can draw a triangle again, same orientation. The short side's 1, the long side's root 3, and the hypotenuse is 9, or 2. Looking at the hypotenuse of the other one. So, if the hypotenuse is 2, and this hypotenuse is 9, but the relationship between the short side and the hypotenuse is the short side is half the hypotenuse, A has to be 4.5. And the relationship between the short side and the long side is you take the short side and multiply it by root 3. So this is 4.5 root 3. Okay, letter number 3. So I'm going to draw 30, 60, 90. It's usually more difficult when you're given the long side, which we have here. So the short side's 1, the long side is root 3, and the hypotenuse is 2. So I drew them similar triangles. Now I'm going to find C by doing a proportion. So 25 is to root 3 as C is to 2. And I'm gonna cross multiply. So it's gonna be 50 equals C root 3. Divide both sides by root 3. And then rationalize it. So root 3 over root 3 is 50 root 3 over 3. So the hypotenuse is 50 root 3 over 3. So the short side, you could either set up a proportion, or the short side has to be half of this. Has to be half of it. So half of 50 thirds is 25 thirds. So it's 25 root 3 over 3. And then number 4, I don't have any angle measures. However, I know that these two sides are equal. So this has to be a 45, 45, 90. So if I draw a similar triangle, the ratios are 1, 1, 1, root 2. So if this is 8 and 8, this has to be 8 root 2. So x is 8 root 2. And I'll slide over for this one. Again, this is an isosceles triangle. These two sides are equal. So I'm going to draw a similar triangle right inside. 1, 1, root 2. So I could set up a proportion. I can do y is to 28 as 1 is to root 2. And cross multiply. So root 2y equals 28. Divide both sides by root 2. But then you need to rationalize. So y is equal to 28 root 2 over 2. But you should reduce this. So this is 14 root 2. So 14 root 2, 14 root 2. Your answers for y. And the next one is a 30, 60, 90. So this actually doesn't even matter, this triangle right here. But basically, I'll draw out the similar triangle. Look the same here. You have the long side is root 3, the short side is 1, and the hypotenuse is 2. So I can do a proportion. 14 is to root 3 as x is to 2. So cross multiply, 28 equals root 3x. Divide both sides by root 3. So x equals 28 divided by root 3. And then I want to rationalize it. So it's root 3 over root 3. So it's 28 root 3 over 3. Okay. So I'm going to skip these two. Let's talk about some of these word problems. Number 10, find the length to the nearest centimeter of a diagonal of a square. So a square has 4 90s and these sides are all equal. The diagonal goes from one vertex to the opposite side. So if the side of the square is 30, this side is 30, you can either do the Pythagorean theorem or I would just do that. This is a 45, 45, 90, so this has to be 30 root 2. And then the next one, the hypotenuse of an isosceles right triangle, so that's a 45, 45, 90, is 8.4. Find the length of the side to the nearest tenth of an inch. So you're going to set up the proportion. 8.4 is to root 2. I'll draw this out here. X, 1, 1, 1 root 2. 8.4 is to root 2 as x is to 1 and cross multiply. And then it's asking you to answer with a decimal. And then we're not doing 13, so let's go down to 14 here. 14 is a mix of a 30, 60, 90, which is the red one, and then the green triangle, which is a 45, 45, 90. So if we know that in the green triangle, the side length, it's isosceles right triangle, this x has to be 45. So I'm going to write, or not 45, but 5. So the y is 5 root 2. Now, if you have this 30, 60, 90, you know the long side is 5. So I'm going to write the long side is 5 right here. And then the similar triangle is going to be, and we're trying to find z and w, but we know the ratios are root 3, 1, and 2. So you're going to do 5 is to root 3 as, let's solve for z. Z is to 1. So when you cross multiply, what's a z? You cross multiply, you'll get 5 equals z root 3. So then you divide both sides by root 3. And then you rationalize it, so the answer is going to be 5 root 3 over 3. So if z is 5 root 3 over 3, the hypotenuse is twice that, so it's 10 root 3 over 3. So before you could do the red triangle, you had to do the green triangle. Okay, now let's look at this one. Okay, this is a trapezoid. So let's see, let's make, I see a 60, so I'm going to make this like this. This 5 is going all the way across. So let's see, this is a 30, 60, 90, which makes, see, I don't know if this is a square. It kind of looks like this is a square, but I don't have enough information. But I do know that this segment is equal to this segment. So let me write 2 root 3 right here. So now I have the long side of a right triangle. So if you can notice, this already has the root 3 nicely in it. So this short side has to be 2. So this distance right here is 2. And this is the hypotenuse, so this is 4 because it's twice 4. And so B is, if all the way across is 5 and this part is 2, B has to be 3. And the last one. So again, you have two triangles. This time you're given information on the 30, 60, 90. So you have the short side. So the short side's 4, the hypotenuse has to be 8, and the long side has to be 8 root 3. Since this triangle right here is an isosceles right triangle, this side is 8 root 3, and then this side has to be 8 root 3 times the square root of 2, because it goes 1, 1, root 2. So it's going to be 8 root 6. And this doesn't break down any further, so there's your answer.